My class is called The Most Deadly Insect on Earth and will be focused on malaria and mosquitoes in terms of parasites and evolution. I am aiming my class towards 12th grade advanced biology, a class that has already had some biology background and has already gone over an evolution unit. My CLOs for this lesson are: students will be able to analyze a scientific reading and make sense of it. Also, students will be able to brainstorm and problem solve as a real scientist would in the face of a global problem. So for this class, I wanted to hit all of the E's except the last one that if I were to continue, would do for the next lesson. It's a lot to fit into one, but I feel like this is the type of lesson where I really wanted to tie everything together at the end. I found it tough to get the right state standards for this class because it's so specific to biology, but I thought within life science a CAS standard as physical and behavioral characteristics of an organism are influenced by varying degrees to heritable genes, many of which encode instructions for the production of proteins. Now this is just saying I like the part for the physical and behavioral characteristics because the reading that my class will be doing is on whether humans infected with malaria are more attractive to mosquitoes or not, which has to do with their genetic basis, as it is an evolution between the parasite and malaria. So my main activity that I wanted to share is the CSR activity. I really think that CSR can be beneficial for scientific readings because they can be so dense and hard to read. So going together in a group and reading over them and talking through them can be really helpful. So I'll give you a second to go ahead and read this excerpt that I took from the reading. It's only 3 pages and then we can move on. So this paragraph is just the part of the introduction, and it's pretty dense within itself. But it suggests that malaria, if you guys didn't know, is also a parasite that is being carried by a mosquito vector that can also be considered a parasite. And so scientists for this reading found evidence that mosquitoes are more attracted to people with malaria, and that is a manipulation by the malaria parasite because malaria needs to be injected into a person from mosquito and then taken back out to be spread some more. Now this is just a little piece of our lesson log that I would have the students fill out that I know we've all seen before. I would have them use their cue cards and then fill these out during their CSR with the full reading. So I would start my class with the introductory question, which is also the title of the class: what is the most dangerous insect on Earth? Now, a lot of people might think something super poisonous or super big, but malaria that is transmitted through mosquitoes has killed more people than wars, and it's a huge problem in Africa, and it was a huge problem in Europe a long time ago. And so I thought this would be a really cool lesson to do to not only spread awareness of something that we don't see so much in America, but something that's still a huge issue, but also get a biology lesson out of it. So I would just need the whiteboard for this, and we would have a very quick discussion before jumping into the real material. After we talk about this question, I would have a true and false clicker quiz if clickers are available, and if not, it could just be like more of a discussion. And I think it would be kind of cool to throw up a bunch of random statistics, like how many people die from malaria in a year. I know that when I learned in an African class, or a class on African history, that malaria still takes out about a quarter of the workforce in Africa per year, which they need. So I was thinking about throwing up some statistics on how many people get it per year, how many people die, how many people are not able to go to school and work per year, just kind of as a little bit of a shock factor to get them hooked. So after this, I would need to do a tiny bit of background on maybe just a really simple version of the malaria life cycle and how it is passed on and why we can't get rid of it, and ask them, what is the vector, like what a vector is, and basically like why we haven't been able to get rid of malaria in anywhere except America. So this would be pretty short. It would just be PowerPoint form, and I would have the students take notes on what hopefully would be a given way that I have them take notes starting at the beginning of the semester, so that it's very structured and they can have kind of something that they're familiar with in the lesson. Next, I would do the CSR activity and have them work in groups of, I'm going to guess, 3, maybe 4 if the class was really big. Have them start with the cue cards, fill out the learning log, and they would each have their own printed version of the reading, and it's only 3 pages. So it shouldn't take super long, but I want them to really try and use each other to figure out what the big words or long sentences mean. And after the CSR activity, I would have us all come together and have each group share their gists. And I believe this is very important because some people might get different important things from the activity, and I want everyone in the class to kind of hear what other groups came up with. Hopefully they're similar, but I mean, it's always great to get new perspectives. So we'd go over that, and then I would try to get them to start thinking about at least, or answer the question, like, how can a parasite make its vector more attracted to the host that it's in, and kind of hint at coevolution between the 2 parasites in humans, and how we haven't been able to get rid of it, and how the parasite malaria is able to be spread more. And this is a very advanced question, but just touching on it would be a kind of a cool thing. I've always thought parasite manipulation was pretty exciting. And so we'd go over that, and if there was time, I would put on the board two ending questions to lead to the next class, and that is, how can we eradicate or at least control malaria in other parts of the world, and what obstacles lie in the way? Now, these are questions that scientists are still figuring out today, but it would be kind of cool to try and get them to think like a scientist. So if there's even 3 minutes, 2 minutes left in the class, I would put those questions up on the board as something to think about for the next class. Now, obviously, most students probably wouldn't think about it overnight, but at least they will have seen it. And then the next day I would continue and have this be our kind of scientist problem solving activity for a lot of the next class period. So the outcomes for this, I hope that students will get to learn a little bit about parasites, parasite manipulation and evolution and vectors and stuff like that, get a little biology out of it, but I also really want to make them aware of a serious problem that's happening all over the world that still hasn't been solved, even though America used to have malaria as a very serious problem, and we've been able to get rid of it. So why can't we do this everywhere else? And so I hope that they can improve their reading skills and problem solving, and just get their minds thinking a little bit about something that will hopefully interest them some.